So power of a quotient and power. Okay, so now we've got kind of a mixture of all these different things that we've been talking about. So we've got a quotient, and they are powers, and they are raised to a power. So again, this distributes in here and there. Let's go ahead and write it out longhand first. X cubed divided by x to the fourth times x cubed divided by x to the fourth. So we would get x to the sixth, because now we're adding these powers, and x to the eighth, because we're adding those powers. Now, we could have jumped directly to 6 and 8 by just multiplying. Power to a power gives me a multiplication. So power to a power, I get 6, for x to the fourth to the second gives me 8. So I could have also written it like this: x cubed squared over x to the fourth squared. And that would be x to the sixth and x to the eighth. Now, would that be my final answer? It actually wouldn't. I could simplify that some more. 6 minus 8 is a negative 2. But I really want to consider, well, where are there more? There are more x values in the denominator, so I'm going to have x squared remain in the denominator. We'll talk about negative exponents in just a minute. Alright, so let's try these. We've got 2x divided by x to the fourth to the third. Now, if you want, you could simplify these x's first, or you could wait and simplify them later. Let's go ahead and just apply this rule first, and then we'll simplify later. So we've got 2 to the third, x to the third, and x to the fourth to the third. So 2 to the third, x to the third, over x to the fourth to the third. Okay, here we're going to multiply, so we get x to the 12th. Here we get 2 times 2 times 2 is 8, x to the third. And then we can simplify, and we get 8. And wherever there are more, I'm going to leave my x. So we have 3 minus 12 is a negative 9, but there are more factors in the denominator, so I'm going to put x to the 9th in the denominator. So again, if I had like 12 factors of x in the denominator and 3 factors in the numerator, 3 are going to cancel out, and I want to know how many left. How many are left, and where are they left? There are 9 factors of x left in the denominator. Alright, so we've got that one. Let's check out this one. Again, power to a power and power to a power, so we're going to be multiplying these two. But this 1/4 applies here and here. So we're going to have x 1/4 of 4 is just 1. I don't even need to put the 1, but I will just for the sake of right now. And 1/4 of 8, y to the 1/4 of 8, or 8 divided by 4, is 2. So my final answer would be just x divided by y squared. Alright, and this one, we're going to distribute this 5 here and there, and also here and there. So we have 4 spots that we need to distribute this power of 5, because this is a product of 2 things, and this is a product of 2 things. So we're going to have q to the 15th, r to the 20th, divided by q to the 10th times t to the 5th. Now, if you don't have an exponent, it just means it's a 1, because there is 1 factor of t there, so it's 5 times 1. Alright, now I'm almost done, but I see the r and the t are different. They don't have the same base. I can't subtract, but these two are the same. I can subtract and simplify. If I have 15 factors of q and 10 factors of q, 10 cancel out, and there are 5 remaining in the numerator. So q to the 5th, r to the 20th, divided by t to the 5th. That would be my final answer. Alright, I've got some problems for you to try. If you want to hit pause, I think I did 1 through 9, and the answers will pop up in just a second. So hit pause, try a couple of those, see what you think. Here's some answers. You can check your work. Again, you want to write down any questions or problems that you have so you can ask me in class tomorrow or talk with your group. Alright, we have 2 more quick little things to show you. Alright, so we've got negative powers and we have, let's see, this is odd. There we go. Okay, we have negative powers and 0 exponent. So with negative powers, whoop, any number raised to a negative power can be changed into a positive power. For example, 2 to the negative 3 is equal to 1 over 2 to the positive 3. Becomes its inverse. So 2 to the negative 3 is in the numerator. When I make it its inverse, this is really 2 over 1. I take that 2, it comes to the denominator becomes the numerator, and then once I've done the inverse, the negative disappears. So here we have, it is only this x to the negative 2 power that's going to change. The 3 is going to stay exactly where it's at. The 3 stays, and x to the negative 2 moves up and becomes x to the positive 2. So it started in the denominator, and it moves to the numerator. Now, why does this 3 not move down to the denominator? Well, it doesn't have a negative 1 power. If it did, then it would also move to the other location, but because it doesn't, we're just going to leave it where it's at. Alright, and here, let's see, let's move all of them, and then we'll figure out what we got. 9 divided by 3, that just simplifies to 3. Alright, x to the negative 4, that puts my x to the positive 4 in the denominator. Y to the negative 2, that puts me my y squared in the denominator. And the 3 I already dealt with, right? Z to the negative 5, I put the z to the positive 5 up in the numerator. And that is how you deal with negative exponents. You want to definitely get rid of them before you start simplifying. Alright, we can just ignore that. You've got the rules right here. So if you have a base with a negative exponent, it becomes the reciprocal and that becomes a positive exponent. It also works if you start in the denominator, like here. If your power is in the denominator with a negative exponent, you can move it to the numerator and it becomes a positive exponent. So that's how you deal with negative exponents. Alright, and the very last one is 0 power property. Anything to the 0 power is 1. Now a lot of people want to say anything to 0 power is 0. That is not correct. Be very careful. Any number raised to the 0 power is equal to 1. You can check even on your calculator. Plug in 4 to the 0 power, plug in 100 to the 0 power, plug in 1,000 to the 0 power, negative 50 to the 0 power. Anything to the 0 power equals 1. X to the 0 power, it doesn't matter what it is, it equals 1. Anything to the 0 power equals 1. Something to memorize. So a to the 0 equals 1. This is something you're going to hear me say a lot. Practice doesn't make perfect. You know, you've heard that, oh, practice makes perfect. But it doesn't. Practice makes permanent. And if you practice something incorrectly, then you're going to do it incorrectly. We want to try for perfect practice, then perfect practice makes perfect. Alright, so I've got a couple more practice problems. You can try those if you'd like to practice some of the things we just talked about. And that is it.